Now that we know this fact is true, square root of negative 1 is I, and I squared is negative 1, we can then perform the indicated operations that we were supposed to. So today, you're going to learn how to operate on complex numbers. There's a real part and imaginary part. So a plus bi. This is the real part, and this is the imaginary part. We always write the real part first and the imaginary part second. There is a purpose for that. I'll share that with you in a little bit. But when we operate on them, we simply combine, whether it be addition or subtraction, we combine the real parts and the imaginary parts. So 4 and negative 6i, or 4 and negative 6 would give you 3i minus negative 8i gives you plus 11i. Easy peasy. Lemon squeezy. Very good. 1 minus I plus 3 minus I minus 6 plus 5I. Okay, if you need to distribute the negative in order to kind of keep up with what's going on, then do that as well. If I combine the real parts, 1, 3, and negative 6 make negative 3. I'm sorry, negative 2. And negative I, and positive 5i make positive 3i. So again, we have a real part and an imaginary part. Let's multiply them. 4 times 7 is 28, and I times I is I squared. Well, what is I squared equal to? So therefore, this is negative 28. Three I times negative 8i would be a negative 24i squared. Positive 24. Negative 2i times negative I would be a positive 2i squared. What does that become? Negative 2. 6i times negative I times negative 2i. Positive 12i cubed. What to do, what to do, what to do? I cubed is the same as I squared times I, correct? What is I squared? Negative 1. So therefore, we have negative 12i. Is that clear? Negative I to the third. Is the I being taken to the third, the negative being taken to the third, or both? Just the I. So, negative, then we have an I squared, and then we have an I. So that would be I to the third, correct? What's I squared? That will cancel out that negative 1 and give me I. I to the 122nd. Negative 1 is a good guess. Question is it correct? You say I. Any thoughts on how I'll figure this out? I to the first power is I. I squared is I to the third is negative I. Everybody see why I to the third is negative I? I to the third is I squared, or negative 1, times I. I to the fourth is I squared times I squared, which is 1. I to the fifth is I to the fourth times I. What's I to the fourth times I? I. So you can see it starts over again, doesn't it? So I to the sixth, very good. I to the sixth would be negative 1. I to the seventh would be negative I. I to the eighth would be 1. So it looks like that if it's divisible by 4, the answer is 1. So what is a number close to 122 that's divisible by 4? 120. So I to the 1/20th power would be equal to 1. So then we'll continue on in the cycle. What would I to the 121st be? And I to the 122nd, negative 1. So if it's even, you know it's either going to be negative 1 or positive 1. If it's odd, you know it's going to be I or negative I. But you have to have a rhyme or reason to figure out which it's going to be. This isn't the only time that this comes up in mathematics, by the way. Trigonometry, this comes up a lot. Calculus, this comes up a lot. So that pattern of 4, kind of recurring. 3i times 2. 6i minus 15i squared. 6i plus 15. Only we don't write it as 6i plus 15, but rather 15 plus 6i. Always the real part first, the imaginary part second. What do you notice about these two? What is their relationship? Starts with a C. Has something to do with Spanish. Rhymes with conjugate. Conjugate. Very good. They are conjugates, meaning that the ending changes. Instead of a minus, it's a plus. And what's special is that the middles will cancel. Watch. 2 times 2 is 4. 2 times I, negative I times 2, and negative I times I is a negative I squared. What happens to the middles? Goes away. And so you have 4. What is negative I squared? 1. So you can see that you can take a complex number and multiply it by its conjugate, and you end up with a real number. It's kind of cool, huh? Try next one on your own. Is that what you got? I made a mistake today during calculus. Somebody asked me a problem or a question on a problem, and I did the problem for them. And somebody else checked the answer key from what I made last year, and it was different. So either I was wrong last year or wrong this year. No two ways around it, right? I used to make more of those when I first started teaching calculus, but now not too often. But Haley Simon has confirmed that this is correct, right? So we'll trust Haley. She knows her math. All right. 4 divided by I. We can also divide imaginary numbers, and you do not leave it as 4 over I. Instead, you get rid of the negative part. To get rid of this, all I have to do is multiply the top and bottom by I. The top, what's 4 times I? Or I, what's I times I? Negative 1. So therefore, 4I over negative 1 would just give us negative 4I. So it turns out that 4 over I is the same as negative 4I. You should write it as negative 4I, not 4 over I, or 4 divided by I. See that trick? A lot of times people want to take this one and multiply by 2I. I don't need to do that. I just multiply by I. Two I times I, negative 2. Negative 3 times I, negative 3I. Negative divided by negative, positive, and I write it like this, 3 over 2, and I put the I right behind it. I won't mark it wrong on the test if you don't do stuff like that. I just want you to understand why it's written the way it is and how it's consistent. I'll show you right after we get done with these two why they do it. 3 over I plus 1. Right, a little bit larger here. If I multiply the top and bottom by I, that does not take care of my issue. Why? I multiply by the conjugate, because I end up with an I in the denominator still. If you multiply by the conjugate, which is I minus 1, we will then be in good shape. Three plus the square root of 1 is equal to 4. Oh, like that. Yes, then you multiply by square root of 3 minus 1. Yes, the conjugate gets used in that way. Very good. Yes. Okay. When you said it's just like, I didn't know how far to push it's just like something. So, yes, in that way, they are like each other. So, 3 times I minus 1 gives me 3I minus 3. So yes, Colton's point, we multiply by the conjugate in other studies, and you're going to do a lot second semester. 3 times I is 3I, 3 times negative 1 is negative 3. Look at it on the bottom. I times I gives me negative 1. Do I have to multiply the inside and the outside? No, because they're the conjugates, they will cancel. I just need to multiply the first and the last. What's 1 times negative 1? So we end up with 3I minus 3 over negative 2. Now, you don't leave it like that. You want a real part and you want an imaginary part. Which part is real, the 3I or the negative 3? Negative 3. Divide that by negative 2. What's negative 3 divided by negative 2? 3 halves. Then we'll do the imaginary part divided by negative 2. 3I divided by negative 2. Negative 3 halves I. This is the way we should write it. And finally, the last one. Again, we multiply by the conjugate. What's the conjugate? This time we have to FOIL the top and the bottom. Top, 2 times 5. 2 times negative 2I, negative 4I. Negative I times 5. Negative 5I. And a negative I times a negative 2I is a positive 2I squared. Oh boy. Guess we'll sort it out in the wash. Conjugates are nice though because we don't have to multiply the middles. 5 times 5, 25, and 2I times negative 2I is a negative 4I squared. Let's simplify the top. What is 2I squared? Negative 2 plus 10, 8. Negative 4I and negative 5I make negative 9I. Negative 4I squared becomes positive 4 plus 25, 29. Divide each of these. 8 over 29 minus 9 over 29I. Can I show you something that's kind of cool? What? Oh, I didn't read it. What did it say? Do I look funny? Nothing wrong with that, right? Why mess with perfection? All right. So, gosh, stop sending me stupid emails. How about we do this? Let's get rid of you. Yeah. Go away. There you go. All right. Okay. Watch this, okay? See if this will connect for some of you guys, but not all of you guys. Okay? If I asked you to do this, okay? I'm going to ask you to do something real simple here. If I asked you to plot the number -2 on the number line, could you do that? Plot it right there. What's the absolute value of -2? 2. Why? Because it's 2 units away from 0, right? So if I asked you to plot 4 plus 3i on the number line, you couldn't do it. We need what we call the complex plane. The real and imaginary axis create the complex plane. So when you plot this, you plot over 4 on the real and up 3 on the imaginary, and you draw this segment. So I'll show you guys this second semester. This is a little bit what we get in the second semester, but watch this, okay? If I ask you the absolute value of 4 plus 3i, think about here. You said the distance away from 0, right? The distance away from the origin. So use Pythagoras theorem. Absolute value of that is 5. Isn't that cool? Is that awesome? YouTube Nation, you're wondering right now, what is the response from the class? Are they all sitting here like, oh, wow. So we'll just take 2 samples. We'll ask you what's going through your brain right now. Emma, what's going through your brain?
Shotgun.
Dominic, what's going through your brain?
Either a lot or not much.
We reserve this for only the great minds, I guess. Okay. There you go. Here's assignment, section 3.4, page 298, numbers 11 through 45. Odd. Shh. Number 15 in the back of your book, it reads 2 minus 2i. Or I'm sorry, I think in the back of your book it reads like 12 minus 2i. The answer for number 15 in the back of your book is incorrect. It should. The people who write your books are human beings, and that's why your book is the 4th edition. I believe it's gone through the 7th edition to take care of all the different errors and additions that need to happen. So just keep that in mind. What's that? Because they're expensive. The question is, do we tolerate this type of nonsense, or do we just discard? Okay. All right.